Okay, we're looking at chapter 5. This means your chapter 5, your chapter 4 homeworks, you should be wrapping them up. I'm going to set the deadline for all chapter 4 homeworks to tonight. Well, tomorrow morning. I'm going to set it for 8 a.m. tomorrow. Because we're done with chapter 4, okay? So if you've been slacking on the homework, that's why I'm setting the deadline, because I don't think some of you realize, some people who really need to know that we're up against a deadline. We're running out of time. So all the homeworks the chapter 4 homeworks will be due by tomorrow morning. The chapter 5 homework will be due by the morning of the final exam. Okay? Whenever we decide that that's going to be. All right, chapter 5. Good news, no bad news. The good news is it calls on something you learned in Algebra 2. Logarithms, logs, not the tree log, but like log equations. Chapter 5 covers exponential equations and log equations. We are not doing chapter 6. There are no graphs on the final from chapter 5. Listen to me carefully. I said from chapter 5. There's no graphs. However, there are a couple on the mini exam. So when we get to them, we're going to make sure you understand it, but we're not going to spend a lot of time on it because it's not in the end game. First, starting with 5-1. We're looking at the idea of inverse functions. It's exactly what it sounds like. Inverse, like inverted, right? It's almost like turning it inside out, okay? If you think about it, the inverse function of addition is subtraction. The inverse function of multiplication is division. The inverse function of exponential is logarithm. That's the relationship between the two, okay? So just how you understand adding and subtracting are inverses, logarithms and exponentials are inverses, okay? Go to this slide. And I think I copied the graphs. I did. Okay. So you don't have to draw the picture in the boxes. Let's start very basic and simple. The first thing that you need to know is the notation for when you have an inverse. So instead of writing the word inverse of h, you can write the h with a little -1 right there. And that looks like an exponent of a -1. It's not. It's just a notation to say h inverse. That's the way you would read it. Go back to trig. Do y'all remember that the inverse of tan is tan inverse? Do you remember that? Apply. If you have me next semester, I hope you remember that. But this just meant that it was the tan inverse. Same concept here. It doesn't actually have the exponential value. I went too far. Okay. So let's start very basic. Instead of jumping right into equations, let's look at just sets. The squiggly brackets means a set of points. Okay, these are just points. Notice the inverse set. Look what happened. What do you notice? They took the x and the y's and they switched them, which makes perfect sense if you think about the visual that you're just turning it inside out. They took the x and the y's and they switched them. So because this was just a set of points, it's called a relation. We're not actually looking at functions right now, we're just looking at a set of points. So it's called a relation. So the inverse of a relation just requires you to interchange the x and the y coordinates. So come right here and practice. Here is the set G of these points. I want you to tell me what the set inverse would look like. set an alarm for 9:30 a.m. Okay, so you should be done. It's just looking up there and saying to yourself, okay, it's 2, 4, so now it's 4, 2. It's negative 1, 3, so now it's 3, negative 1. It's negative 2, 0, so now it's 0, negative 2. And that's it. More of these, right? What does it look like graphically? I copied this for you so you didn't have to copy it down. Graphically, the original set is right here in blue. And then the red set is the inverse set. What do you notice about the spatial relationship? It's symmetrical to that dotted line, right? That dotted line is the equation y equals x. I don't know if you remember from geometry, but the line y equals x is called the line of symmetry because it's used to represent when you have a function graphed with its inverse, it's reflecting over that line. Here's how you remember this. What did we do when we found the inverse? We took x and y and we switched them. So the way I remember it is I say to myself, y becomes x, x becomes y. So it's reflecting over the line y equals x. So that's what it looks like. Now let's bump it up a notch. Instead of looking at ordered pairs, now let's look at just an equation. This is not a function, it's just an equation. We no longer have an ordered pair. Now we have an equation with a y and an x in it, but the concept is still the same. You're going to interchange the variables, right? So coming back here, we interchanged the coordinates in the ordered pairs. Now we're going to interchange the variables. So y becomes x and x becomes y. So right here, it says find an equation for the inverse of the relation. There's a y. There's a y, so it becomes x. There's an x, it becomes y. There's another x, so there's another y in there. Now let me pull my math lab so I can tell you exactly how far they want you to go with that in the homework. Did I leave the 5 off? Oh, yeah, the 5's important. I'm sorry. I probably got frustrated when my It is. When my twinkle lights fell. Let me go fix that. That's definitely supposed to match. It should match. It's just the X and the Y's. I'm looking at the homework. The first 2 questions are the ordered pair ones. This third question, they give you the equation and they ask you to find the points on the inverse. You just pick numbers and plug it in. All right, so far we're good. Look at this right here, this graphic. This is going to help you with number 3 in my math lab. These are T-tables, T-charts, right? This is the inverse. So let me come over here. This is the original relation. This is the first one. And then this is the inverse. If you are asked to plot it or to graph it, don't make it complicated. In the relation, you would just pick some numbers for x, plug it in, and see what you get for y. And then those, you just plot them, right? So I'm going to make a note. Pick numbers for, now I'm going to switch it. If you're graphing the inverse, do you want to pick numbers for x and then solve, see what you get for y? No, because how many y's are there? There's 2 of them. See, because it's the inverse, you're going to switch your thinking. Instead of picking a number to plug in for x and see what you get for y, you're going to pick a number and plug in for y and see what it gives you for x. So pick numbers for y and find x to get an inverse t-chart. Now, I say that to then now say, or you could go back to your understanding right here, and if you have some ordered pairs from the original, right, you could just switch them. So you could have 2 possible methods. So if you had some order, if you don't like this backwards thinking, then you could just do the normal one, get some ordered pairs, and then to get the ordered pairs for the inverse, you would switch them, and then you should still get the same thing should you pick numbers for y and plug it in to find out what x is. Okay? All right. Next slide. We're going to talk about 2 things that you've heard before. If something is an inverse, or if something is one-to-one. Now we're getting to functions. Notice the word functions right here. We're no longer looking at ordered pairs as a relation. We're no longer looking at just an equation in general. Now we're saying that there is an inherent property that exists, and that is it passes the vertical line test. Remember that? That's how you know when something's a function. Okay. Look at these 2 examples right here. How did I copy it on yours? Good. Okay. So this is saying here are the years that they're looking at compared to the price of a stamp. Stamps in 2006 were 39 cents. In 2014 and 15, they were 49 cents. So the arrows are saying in 2006, they were 39. In 2007, they were 41. You notice that some of them, they didn't change, right? So for these 3 years, I tapped it, they did not change, okay? If I wanted to find the inverse relation, I would just flip the arrows, right? Isn't that the same thing as flipping the x and the y? Okay, so watch my screen. Now the arrows have been reversed, right? Now the question is this a function? It is not a function because now the value 44 is being assigned to 3 different numbers, which would be the equivalent of me saying, here's an equation, I want you to plug 44 in. And if you got 2009, you got 2010, and you got 2011, and all your math is right, this would be it would be unhelpful, right? Because you all 3 plugged in the same number, but you got totally different answers. That means it's not a function. Okay? So we're going to take some notes and we're going to make a circle. Now I know on your paper I photocopied the arrows going to the right, which is the original. That's the normal one. Now we're going to, I'm circling right here. You can still circle the same things. My pen has selective writing right now. Is there another issue in this? 49 is another problem. 49 is coming to two different assignments. So the question here is, if I was to take the original and reverse the arrows, then that means I'm looking at its inverse. And the question is the inverse a function? And we would say inverse is not a function. And the reason why is because an input can only have exactly one output. An input oh my word, this is going to drive me nuts. No, I'm wondering, this has happened. There's a sensor behind the cover, and if it starts falling, it creates the blank spots. Do you need towel? You good? All right, coming over here. Look at this one. Just a number and then cubing it, right? All right, if I reverse the arrows, okay, don't show me. If I reverse the arrows, is it going to be a function? Yeah, because there's no discrepancy. The inputs now still just go to one output. So yes, this inverse is a function. And it introduces the new concept that goes to the next slide and is called 1 to 1. It's called 1 to 1. Let me explain what 1 to 1 means. The visual is right there in front of you. The inputs have exactly one output and all the outputs are different. Right? That's the concept behind 1 to 1. If you go back to your understanding of functions, x values cannot be assigned to multiple y values because then that wouldn't pass the vertical line test. An x value can only be assigned to one y value. Okay, so, however, if I had a t-chart of like 1, 2, 3, if 1 went to 5, and 2 went to 5, and 3 went to 5, that's okay, because that's the output, right? The output can be repeated. It's the input that cannot be repeated. The concept is, here, this would be meaning no matter what x is, y is 5. So this is actually that horizontal line, which is still a function. Now I'm showing this to you because I need you to understand that if it's 1 to 1, it means that none of the outputs get repeated. They're all distinct. And that's, like, here's an example of not 1 to 1 because they definitely get repeated, and this is what it looks like. It's this horizontal line. This is an example of 1 to 1 because none of the output values are repeated. Okay? Which takes us to the next slide where you actually see the math definition behind 1 to 1. Okay? Look right here. Not a lot to write, you just need to understand the math behind it. If a function's 1 to 1, it means there's different inputs with different outputs. The math behind it is, if A does not equal B, which means if you have two different numbers that you're plugging in to the function, you're going to get two different outputs. That's how you interpret this. This is saying, pick two numbers that are not equal, plug them into F. You should get two answers that are not equal. You see how to read it now? Now, here's the flip side of that. What if it is 1-to-1? Another way to say, or to verify it algebraically is, okay, well, if the outputs actually are equal, right, then were the inputs equal? Because if the inputs were equal, then that meant you plugged in the same number. That's why you got the same answer. So there's two different ways to write it. One way is to say, hey, pick two different numbers, you should get two different answers. The other way to write it is, hey, I got two of the same answer. Like I got the answer twice, the same answer. Well, then you must have plugged in the same number. Okay? Try to help make sure you understand how to read that. You're going to see how to actually apply it in a second. This right here is just reminding you that the little -1 is not an exponent. It's the notation for F inverse, okay? Now, there is a relationship between domain and range of a function and its inverse, and it goes back to right here. Okay, look at the graph, right? Look at the symmetry. Y became X, X became Y, which means the domain over here becomes the range over here, and the range becomes the domain. That's the relationship, and it's all because of that right there. Okay? So coming back to this one, this is saying to you the domain of a 1-to-1 will be the range of its inverse, and the range of a 1-to-1 will be the domain of its inverse. Okay? I know that doesn't interest you. Let's practice it in the algebra so you can see what you have to know. So right here, given the function f described by f of x equals 2x minus 3, prove that f is 1-to-1, which means prove that it has an inverse, that its inverse is a function, okay? To prove that it's 1-to-1, you're going to have to do some algebra, and it's going to feel kind of weird, but this is that higher level math. So go back to this right here. This one's easier to check than that one. This one's easier to check. So what we're going to do is we're going to start with the assumption that f of a has to equal f of b. And then we're going to try and see if we end up with a equals b. You might be thinking, what in the world am I saying? Here's how you do it. So we're going to start with f of a equals f of b. Which means plug A in, plug B in to that, right? So if I plug A in, what do I get? Plug A in here, what do I get? 2A minus 3. Plug B in. 2B or not 2B. Sorry. 2B minus 3. After you plug A and B in, now see about if you can manipulate it. Like try to manipulate it by doing whatever you can to both sides to get it down to just A and B. So the first thing I see is I could add 3 to both sides, right? And then those would go away. You with me? So I'm going to add 3 here and add 3 here. Those would cancel. And I'm left with 2A equals 2B. Now what can I do on both sides? I can divide by 2, and I end up with A equals B. See, that was a lot easier to check for. So, I'm going to put a check mark here. So, if f of A equals f of B, which is where we started, right? Then we came to A must equal B. Now here's the new part. What does that mean? I just did all of this algebra. Like, what does it mean? It means that that function is 1-to-1, which means if you go to the table and look at its running t-chart, you're going to see a relationship like this one right here. Okay? Where every individual x value is assigned to a brand new y value. Alright? So let's make a note. So f of x is, now how do you write 1-to-1 without having to write it out? This is the abbreviation, 1:1. That stands for 1, 2, 1. Go to the next example. Let's try it. Given the function g described by this equation, prove that g is not 1-to-1. Now they're telling you from the get-go right here that it's not 1-to-1, which means that your final answer should be that A does not equal B. We should come down to the conclusion A does not equal B. Up here where it said prove that f is 1-to-1, that's letting you know that you should be able to get to A equals B, okay? All right, so set it up. F of A equals F of B. All right. I'll write right here. F of A equals F of, oh, it's G. It doesn't matter. You can call it F if you want. G of A equals G of B. Plug it in. So I'd have A squared equals B squared, right? Yeah. What do you get when you square root? There's the problem. So here I would get plus or minus A. Here I would get plus or minus B. It's too vague. Like, does positive A equal negative B? No, not possible, right? Does negative A equal positive B? No. So it's too ambiguous, right? So in this case, A does not equal B because they have positive negative signs. So here's what we would say to ourselves. No. In this case, G of X is not 1-to-1. What does it look like on a graph? I think I copied that for you. Yeah. All right, so look at this right here. Let's wrap it up. Let's figure out what you just discussed and understand it. So blue is the function g. Red is the inverse. Okay? And they get that. There's that dotted line. Y equals x. So that's how they get it. They're reflecting it over the dotted line, y equals x. Okay, go to the blue graph. Does it pass the vertical line test? Blue. Look at mine. Blue. Does blue pass the vertical line test? Yes. So g of x is a function because it passes the vertical line test. Go to red. Does red pass the vertical line test? No. Y'all see that? So red, g inverse, is not a function. Here's the big picture. how can I determine from a graph if a function has an inverse that's also a function? Now, you got to follow what I just said because it's really confusing. How can I look at a graph, the original, and determine if its inverse will be a function without graphing it and without doing the algebra? It's called the horizontal line test. It's called the horizontal line test. Go to the blue. Imagine a horizontal line cutting across the blue. You see it's over here. Does it pass the horizontal line test? No. That means that when you reflect it and graph its inverse, it will not pass the vertical line test. You with me? So let's write this down because it's a lot to say. It sounds very similar. It's very important, and it's actually really easy to understand. Every single one of you seems like you understand horizontal line test, right? So let's write it down. I would write it in find a space, maybe in that same slide towards the bottom. Find some space, maybe like right here. Y'all got space? Yes? Okay. Let's write this, and hopefully my board writes it all. We're going to write this. If okay, I got it. I know what I'm going to do. Yeah. I'm going to go to
Just write it on the whiteboard.
Oh, we go. I'll write it right here. Over here. If f of x is 1 to 1, right? If f of x is 1 to 1, then the inverse f inverse is a function. If f of x is 1 to 1, it means its inverse is a function, right? Now I'm going to write another thing. If you don't have room, write it somewhere. This means, how do you check for this without doing the algebra behind the 1 to 1? If f of x passes the V line test, I'm sorry, not V, H. I got excited. If f of x passes the H line test, horizontal, then its inverse passes the V line test. So if the original function passes the horizontal line test, then should you graph the original function's inverse, it will pass the vertical line test. Which means the horizontal line test determines if it's 1 to 1. So if the function passes the horizontal line test, that means it's 1 to 1. Okay? I can try. Okay, go to the next slide. So let's look at this one right here. We are practicing the horizontal line test. Okay. Look at A. Does A pass the horizontal line test? Meaning if you just drop a horizontal line anywhere, you're making sure it only touches the graph in one spot. So does it pass? Yes. That means that if I was to find that inverse equation, it would be a function. That means it's 1 to 1. Look at B. Does it pass the horizontal line test? No. There's a spot right there. It definitely does not. That means this is not 1 to 1. That's what it means. C, yes. C is passing the horizontal line test. This means it is 1 to 1. Same thing here. It is a 1 to 1 function. Meaning the T-chart would be a list of distinct numbers, never repeating. Alright, what about D? D is not. Got a big problem right there, there, and there. So it is not 1 to 1. Right? Okay. Any questions? Now let's get to finding the equation of the inverse when it has one. Okay? If you forget how to do this, the steps are written right here. Read the directions. Determine whether the function is 1 to 1, and if it is, then tell me the formula, which means find the equation for the inverse. Well, this is what type of graph. You should be able to do this in your mind with some of these, because you should understand where the graph is. That's what type of graph? Linear, which means it's slanted like this, right? So is it going to pass the horizontal line test? Yes. So is it 1 to 1? Yes. Which means we can find its inverse. So we're going to make a note. F of x equals 2x minus 3 is 1 to 1 because it's linear. So let's find its inverse equation. Look at the steps. Where the f of x was, you need to replace it with a y. Then go back to the very beginning of this section. What did we do with our x and y's? We swapped them. And then the extra part here is now you're going to solve for y because they want the equation. So here it is. This is y equals 2x minus 3. So swapping them, I would have x equals 2y minus 3. Now you're going to solve for y. So add 3 to the left. And now divide by 2. And I just wrote the whole thing over 2 because this was just what's the equation. I'm looking at my notes. Yeah, this is homework example number 8. They just wrote the whole thing over 2. So this would be x plus 3 all over 2 equals y. Now, that's the answer, but technically they want you to actually go back and now replace the y with the function notation for its inverse. So I'm just going to draw an arrow to say, okay, so f inverse of x is x plus 3 over 2. And that is question 8 in your homework. Let's go to the next example. Y'all good? All right, look at this example. Did I copy the graph for you? We have f of x equals 2x minus 3, and then we have f inverse of x equals x plus 3 over 2. These are the two we just did. These are the two equations we just did. It says graph it using the same axes and then compare. I already graphed it for you. It's right here. Notice the original is the green, the inverse is the red, and once again they have that nice symmetry over the line y equals x, right? Here's the takeaway. You don't have to write the entire sentence. This is already on there. The takeaway is that when you graph both f and f inverse on the same picture, you will notice that they have a nice symmetry over the line y equals x. Okay? Go to the next slide. All right, consider g of x equals x cubed plus 2. Determine if it's 1 to 1. If it is 1 to 1, find the formula for its inverse. Then graph it. The fast way to determine if it's 1 to 1 is to enter in y equals and check for the, I'm going to call it the H-line test. You're checking the graph to see does it pass the horizontal line test. Now, I already graphed it for you on here. The one you need to focus on is this curve right here that you can see on mine. Okay? That's the original. Does that pass the horizontal line test? Then the answer is yes, it's 1 to 1. So let's make a note. Yes, it's 1 to 1. We're going to make a note because it passes H-line test. If it passes the horizontal line test, then that means you can keep going. They want you to now find the formula for its inverse. That means find the equation of the inverse, which means to do what? Swap x and y and solve for y. This means swap x and y. I'm going to just put x with an arrow to an arrow. Swap x and y and solve. All right, so we got y equals x cubed plus 2. Swapping would look like this, right? Yeah? All right, I'm going to subtract the 2 over. But here's a beautiful thing. I can act like I didn't know to release y'all. So I'm going to finish this before you go, because there's no bells. So if you don't like your second block, you're welcome. Now I need to get y cubed to be just y. How do you undo y cubed? You cube root it. Don't panic. Don't panic. You're just writing it. You're not actually doing it, you know? So this is cube root here, and that is your equation. So the cube root, I'm going to switch it. We would have the cube root of x minus 2 equals y. They want you to actually write your fancy notation. So you can just say f is g. G inverse would be the cube root of that mess. And graph it. Well, I already graphed it for you. So looking at the graph, you can see, now you can see, does the red graph pass the vertical line test? Yeah, that's because the gray graph passed the horizontal line test. Okay? There was one slide left. I will show you that at the beginning of class tomorrow. It's not terribly important. You need to start the 5-1 homework. It's falling asleep. Yes. Why? Is it because of the rain or is it because I'm boring? I don't think you deserve one.